So, hi Chinthaka,
Hello, Boby.
how are you?
Good. How are you?
Fine. So, our previous class was about
Strain
gauges. That was strain gauges. That's what this image shows. Yes, yeah. So, we briefly discussed about how strain gauge works, why this kind of specific shape and things like that. Yes. Then we took, tried to represent the strain gauge as a resistive sensing element. Yes. Like a resistance Rx with a nominal resistance R0 and X, which is the variable, K is the transformation constant. So, if the resistance is changing linearly with respect to measurement X, we can represent in this way. That's what we mentioned. Correct. One thing we realized is in this, there is the equation is like 1 plus Kx, yes, or minus Kx. And the Kx quantity may be very small, yes. So, how do you measure that Kx when the 1, which is probably very large compared to Kx, is present there? Correct. So, then we brought in the Wheatstone bridge, which somehow looks at the difference alone and gives an output like this. But unfortunately, we found there is a Kx by 2 in the denominator. This gives a nonlinear output. Or if Kx by 2 is very small compared to 1, maybe we can neglect. Yes, but that's not the case always. Yes. Then we decided to use a little bit of electronics to solve this problem. So here we have an op-amp and almost the same circuit. This is R0. And then we have seen that output V0 is equal to Vs into Kx by 2. So the denominator term is gone. Yeah. And of course, the offset 1 plus, which was like an offset, that's also removed. This is, we are quite happy now. Right. Although you were mentioning that not much amplification here, because it's just Vs multiplied by Kx by 2. Kx is a small quantity. So then we were saying if needed, further amplification can be done using other amplifiers. Right. With some gain. Yes. This is what briefly we discussed in the previous class. What shall we do today?
So, I was wondering, what if you do not know the direction of measurement? So, before we knew, right?
Yeah.
So
correctly. In this case, I knew, okay, the strain is in this direction and we made the strain gauge in that place. That's correct.
And we placed it accordingly.
Yes.
But what if you don't know? Or what if there are multiple directions that we need to measure? What's the solution to that?
It's not easy, I think. I may have to measure once, rotate, measure.
Like some device that
correct
kind of goes around.
Yeah. That's not feasible.
That's not optimal, is it?
Yeah. Because to get this same strain experienced by the strain element, we need to firmly fix strain gauge to the whatever the structure is. So that's a problem.
And you can remove and
correct. You can remove maybe a couple of times and then
it will be gone.
Yeah, you'll have to buy a new one. So that's not the solution.
So can we have multiple strain gauges? Is that a possibility?
Yeah, maybe in all directions and then.
Yeah, or the directions that we think that we're measuring.
So one way could be, I can, like you said, we can have maybe let's say we take XY directions. If I have a strain gauge which is sensitive to X direction alone, okay, and if I have another one which is sensitive to Y direction alone, then it may be possible to resolve, right? Because as we know, if you have a point here, we know it can be represented with X and Y. So something similar could be possible here.
Right. So you're talking about, in this case, if you talk about X and Y, you're saying?
I will have two strain gauges. One strain gauge aligned in this direction. Something like this. This will be sensitive to strain in X alone. Okay. And another one in the other direction, Y direction. This can be kept very close. Right. In fact, when we make, it can be made as a continuous structure also. I think I have a figure here. Something like this. It could be something like this. Where this one, for example, this is sensitive. I mean, this has structure like this. So that means it is sensitive to X direction. Yes. While this is sensitive to Y direction. Yes.
But this is just one structure.
No, it is one structure. So I have a contact here. I'll make it clear. So this one is sensitive to X direction. This is sensitive to Y direction. And we have electrical contacts available at these 3 points. Okay. So I can get an RY here and an RX here.
And both structures are free to move.
So this will be pasted on the structure that where we want to measure the strain.
Right.
So it gives the X and Y components of the strain. Okay. Now one could also place in this way. It can be one on top of the other as well. Right.
I mean, are there any advantages or disadvantages of placing it in the second way compared to the first way?
Suppose, it depends on the applications. Here, if you want to measure the strain at this region, you may not be able to introduce something like this that requires slightly more area. Right.
What about freedom of movement of the two strain gauges? Does it matter how it's?
So they are actually, both of them are firmly
placed.
Just
like having two separate ones, but we have it in one.
Yeah. So the bottom one is glued correctly to the structure. Then the one above is again firmly glued to the bottom one. Right. So
on top of each other.
Yeah, on top of each other. So if the structure undergoes strain, expansion or contraction, both of them will experience that depending on the direction of the strain. Right.
But the movement of the bottom one, it will not be restricted anyhow because something's on top of it.
Yeah. So
that's what we are saying.
So one thing is, all these are in probably micrometers.
Very much.
Yeah. So these are free to expand and contract depending on the structure that undergoes strain.
Right. Okay. So now, so we can then.
Yes, we can. We can. Like we have seen the previous photograph. See, you look at the structure here, such a big one.
Right.
So that's the one carrying the load. And the strain gauge is such a small element, very thin. Right. So it can freely expand and contract compared to the structure. If structure undergoes strain, this will undergo for sure strain as well. It just fetches that information. Right. Like we mentioned, the strain gauge will not bear the load. Right. Correct. Yeah.
So will I'm not sure if it's the resolution, but the measurement range increase if we have multiple ones in all different directions, not just X and Y. With X and Y, we should be able to measure, calculate.
Yeah.
Any.
Yeah. So the best one could be if you can have one aligned to the direction itself. Right. Because it will see the full component. Right. Now, if it is X and Y, of course, if you have a strain in this direction, you will see the components here, which will be a scaled down version of individual.
Yes. They won't see the full
Yeah.
effect, but
Yeah.
based on the two measurements, you'll be able to work out
Yes.
the result of this.
Yes. Now, there are also other configurations where, this is 90 degree. You can also have maybe 3 120 degree directions. Something like this. A strain gauge sensitivity to this direction, another one in this direction, another one this.
I think this is what I was trying to get at before. Asking you can have multiple ones.
Yes.
So that is also possible.
Yeah. So once you have like this is also, maybe one of this will be more close to the actual strain. But of course, once you have information in these angles, you will be able to resolve it into the actual direction.
And the op-amp based method technique that you used, we can use the same for.
So this op-amp based method we used, it's actually we have derived it for one sensing element.
Yes, and one direction.
Yeah. That direction could be plus or minus. It can increase or decrease because it was plus or minus kx by 2 into Vs.
Correct.
So it will give the either x direction or y direction. Now, you will need separate units of that for the x and y.
Right. But the principle remains the same.
Yeah.
So that means if you have more,
yeah,
you just get a bit more complicated when it
that is
have many other.
That is true. Yeah. In this particular case where output is dependent on the direction, x and y directions, you need those information at the output side.
Exactly.
Only then we can resolve it. Right. Yeah. So the 120 degree I mentioned, it could be like this.
But here, this 120 degree, there are 3 separate components. They are not one component like your x and y that you showed before.
So this diagram you are comparing.
Yes.
That is true. Here, when this is one way to realize it. Right. This also, I could split it here and have 2 separate strain gauges. It's only, what shall we say, a one way to fabricate it.
Right.
Yeah. So here also, maybe here there is a possibility to have a common node. While here, that may not be possible.
Yes.
If I decide to this together, that's okay. But then I cannot have this also together.
Correct.
That's true. Yeah. So we need that information, 3 values separately. So that common node may be difficult in this case.
And you're probably introducing more human error in this case because now you have to paste, if you're doing it at different angles, right? Whereas in the first example, it's already fabricated.
So now there is a good point. See, this 3 strain gauges,
yes,
it can be made on same substrate.
On top of, and then you paste that substrate on the target.
Yeah.
Okay.
Or when you etch this shape, it can be from the same material, from the same sheet, I can etch and get these shapes.
Right.
So that way they are correctly placed.
Right.
What you're saying is true. If I take each strain gauge separately and manually place, then instead of 60 degree, it may be 62 degree, all this are possible. Correct.
Degree error.
Correct. So this is also very similar. Instead of 90 degree, they are at.
And here we have 3 there?
No. We have 3 there. So this is one. This is another one. This is third one. So these are some of the configuration. They are called as Rosette strain gauge.
Rosette means that they are in different directions.
Yeah. When you want to resolve strain into x and y or in 120 degree apart and measure, this can be used.
I'm not sure if you talked about the materials that you use for this strain gauge.
Strain gauges? Well, I think we mentioned somewhere it's nichrome could be one of the materials. I think some,
Okay.
I think,
Right.
yeah. And then we were also saying this semiconductor type has more sensitivity.
That's right. You're
Correct.
Yes.
Correct.